Hello and welcome to the Parents' Guide. This is where you'll find out what's going on in schools and hear some of the key issues being discussed from the parents' point of view. If you have school-aged children, this programme is for you. We'll be focusing on primary science with two parents, Kieran Monaghan and Maria Rose.
Hello.
Hello.
We're also joined by an advisor with many years' experience in science education, Anne Goldsworthy.
Hello.
We've been looking at programmes from Teachers TV and we'll be showing some extracts during our discussion. These programmes were made for teachers, but they also open up a window for parents to look into classrooms and see what's going on in schools today. In our first extract, we visit the classroom of a newly qualified teacher, Helen Ackerman, who uses the story of Little Bear to teach 5 to 6-year-olds about light.
As part of the children's experiences of light and dark, they're exploring different activities, including a light source table, a dark cave, a light box, small caves made out of shoe boxes, and a story box using props and mirrors. Sam and Laura are predicting which of the coloured stick people they'll be able to see in the cave with no light source.
That's right, we've got some questions here to help you with your prediction. Which ones?
You'll be able to see the silver one.
You think, do you? This one here?
Yeah.
You'll be able to see him in
And the white one.
in the dark. Why do you think you'll be able to see him in the dark?
Because cornfield is really, cornfield is really shiny and dark.
You mean foil?
Yeah.
Foil's really shiny. Right, OK. Where do you want to put that then? Right, you're predicting that this one will be one we can see in the dark.
They've decided that they will need a light source to see the red and black figures. All the figures have already been placed in the cave. Sam and Laura are now testing to see which figures they can find without a light source to help them.
I found that now found yellow. No, I forgot yellow. Well, that was white one. We haven't covered up this, haven't we? I made the dark because we're making the village first.
Yeah, Mrs. Palmer was a bit slow there, wasn't she?
Where are you? Hello, Laura.
Here.
Here we are. Here are some light sources to help you to see in the dark.
Right, one.
How is it now finding the people in the
A
dark?
bit easier.
Maria, that was the sort of thing that all children love, going under a blanket and making a cave. Did you think it was a good lesson?
I thought it was a fantastic lesson. It was one that the teacher obviously put a lot of thought into and planned very well and built up some resources for the children to use. I thought it was a really enjoyable lesson.
Were you bothered about the sort of safety aspects of them clambering around in the dark under blankets and things like that?
Yeah, there was just that small issue that the teacher balanced rather precariously a big table on top of two other tables, and I thought that introduced an unnecessary element of risk for the very small children that were using it.
Kieran, what did you think about the use of scientific language? Do you think that was too complicated for very small children?
I think the words refraction possibly can introduce an element of confusion for the children. It's a long word, and sometimes children associate long, complicated words with complicated actions and things. So they might be scared about that word, and it might be a word that they might not remember, whereas the way light bounces might be an easier way of describing something. So finding an easy way to describe something is a lot better, I think, for younger children.
Do you think there's a risk that might put younger children off science, though, by the fact that they can't understand some of the language that's used?
There is a risk, yes, but I think that teacher was able to demonstrate a real vocation for teaching in terms of not just using long words, difficult words, for getting a message across, and she demonstrated that by obviously spending a long time preparing and collecting together some very, very exciting props which will create in all those children's minds a lasting memory.
Do you think there's a danger, though, that it could get really confusing with children who maybe don't quite understand the language, and then parents who hear what the children have been doing at school during the day and don't quite understand it either?
Well, yes, exactly. Like the word refraction, I probably couldn't give you a really good, correct definition of that word myself. So for children to understand it and to come home. If they came home with a misunderstanding, most parents might just smile and say, yes, okay, darling, yes.
Well, I mean, Kieran's got a scientific background, Anne, so he's not sure he could explain it. So what would the average parent need to know, do you think, to understand what their children were bringing home?
I think the important thing for parents is not to worry about this too much. There may be some terms that their children are using that perhaps they don't understand. But the big thing is to just get the children talking about things and help them say for themselves what they think is going on there. And if there is some concern about the word, then you could have a conversation with them and say, well, I wonder what that word means, and I'm not quite sure about it either. Maybe that's something you could be asking your teacher about later on.
Do you think that, Maria, that experimental side of science is something that could make it into a more interesting lesson for many children than maybe English or maths?
Certainly, I think that when the children can do that hands-on stuff in class, that makes it more exciting, and it gives them something to hang on to remember, and perhaps to take home in an experiment as well.
I think that's one of the things we're trying to do in science very much in schools today, is to actually test out children's ideas. So they have ideas about something, like those youngsters did about the things they could see in the dark area, and then they go in, then they test it out, and then they see if their ideas were right. So we're trying very much to teach them how we go about science rather than just the science knowledge. It's a mixture of both.
Well, we're all agreed on the importance of starting children with science as early as possible. And in this next example, we're going to look at a class of Year 6 pupils with their teacher Zoe Lowe, who has introduced the special symbols and language of electrical circuits. In the extract, we see the children making real circuits with bulbs and buzzers.
Okay, that should work now. Oh, they like this.
Now, what have you just done?
We've added another crocodile clip and added it to that.
Okay, so Zoe has connected. So we've now got a bulb that's working. What do you notice about the brightness of the bulb?
It's not as bright because it's only using one cell.
It's only using one cell. Fantastic. Yeah. Just grab hold of that buzzer for me. Everything working? Yeah. Yes? So why do you think that's happened? Because we must have had an electrical circuit, we must have had a current. You've now got almost two, haven't you? You've almost created two separate circuits, but running from the same. Fantastic. Let's disconnect before I get a headache. Draw that and write me down what you did.
We had an extra battery to try and light the bulb and it didn't work as well.
Have you added a battery or a cell?
A cell.
Thank you.
Jake, look at our switch. Oh,
Those are the questions up on the board. Have a good look. You're going to have a chat with your partner in a minute, and I'm going to give you about a minute and a half. You are going to tell me what your partner said. Okay. Go.
I'll do it first, then you ask me. One thing you've learned tonight.
how to make a C.
One thing you found difficult tonight.
Well, I found putting the circuit together quite difficult.
If there's not much in the cell, there's not much light.
I've learned how to draw and do the symbols correctly. I found it difficult when we tried to collect them all together.
Kieran, what did you think of that lesson?
I guess I had mixed reactions to that, because I was a little bit disappointed by the type of equipment that was being used and the items that the teacher used to instruct the children, because I thought they were just too boring and old-fashioned, if you like. But sometimes maybe keeping it simple is a good way of doing it. She obviously would be able to reinforce the ideas into the children's heads by using the names for all the circuit components, the diagrams, using the circuit board, and then they did a bit of play acting at the end. So I thought it was a good class, but I thought perhaps some of the ideas were stagnant.
Maria, do you agree with that? Did you see the lesson in the same way as Kieran?
No, I thought that it was an enjoyable lesson. I thought she was, again, very clear about its objectives and kept getting the children to refer to the key words, so they got used to using that language. And again, because she engaged them in the tasks with the resources that she had, I think that they seemed to be genuinely enjoying what they were doing.
And so Maria thought it was a well-resourced lesson. Kieran thought the equipment was a bit old-fashioned. Do you think it was a normal level of resourcing for a primary school classroom today?
I think the circuit boards that they actually worked on are quite unusual in primary classrooms. I mean, great if you have them. But most primary classrooms now have a good supply of electrical equipment, so children are making circuits with the wires and the bulbs and the buzzers and so on. I think maybe the old-fashioned bit Kieran was referring to maybe was the whiteboards. Am I right that was the holding it up?
I'm referring to it all really, because I suppose from an engineering background I can see the different ways of doing things, and to make it more exciting for the children. I thought it was a bit chaotic, too many wires and things all around the class. Perhaps to have it more structured, and perhaps to focus the children's attention on doing specific things without allowing them so much rein to get it wrong and to wire things up wrongly too much. Yes, that's a good way of learning, but I think you need to learn to do it right first and not have too many places where there's the wrong thing going on and only one teacher trying to control all of those things.
There's quite a fundamental point there about his teaching style, though, and in science in particular, allowing children to experiment and maybe make mistakes. Is that the right way to do it or the wrong way to do it?
I think you need to be clear always what the lesson objective was, and in this lesson she was trying to get across the idea of symbols and relating those to the components. She then allowed the children free range to make any kind of circuit that they wanted, to then be able to represent that in symbol form later on, which they seemed to be doing, and that bit they seemed to be being effective about. There was also elements of bits where, yes, they were constructing things and finding things out that way and getting things, what you would say, sort of maybe not doing it in quite the correct way. But again, you know, if that was picked up later, then that's fine. The main purpose of that lesson was very clear, and I think the children got across, and they seemed to thoroughly enjoy having a good time with electric circuits. It's always a lesson that seems to go down well. The children love handling the stuff and finding out how it works.
Kieran, do you think most parents are aware of what their children are doing in science lessons at school?
I do think so. I think the children, because it's such an exciting subject, do come home and say, "Mommy, Mommy, we did this today." And they'll run and get the torch. I know my two children are all the time wearing out the batteries in our torches. But I might be being too critical of that class, because there was so much, as you say, good things going on. And at such an early age, and allowing them to get a flavour and sample science at that age is so important.
Do you think most parents really understand what goes on in the science curriculum?
No. I don't think they understand I think most parents would be surprised to learn that their children were learning, for example, about electrical circuits in Year 6. I know certainly I didn't do that till secondary school. That's one example. And I think more and more these days in school our children are studying, particularly science, in the science curriculum, subjects that we didn't cover till we were a bit older. So that seems to be true from my experience.
Well, it's certainly a long way from my primary school days, and perhaps with science, it's a good idea to look outside the school for help. And in the next clip, that's what we're going to see. It's Science Week in the Royal Kent School in Surrey, and Danny Waite, a consultant metallurgist, is helping teacher Tony Palmer and his class of 10 and 11-year-olds to build water rockets.
We now got to do the final task of making your rocket, which is a nose cone. Hold the card, hold the two corners and bring them in together to make a cone. Make sure there's no gap there, so the sellotape covers the gap, and then we trim it round and put it on the nose of your bottle and hold it around with tape again.
This is a really good lesson because we don't usually do things like this. It's really fun.
We get to do some hands-on stuff rather than just like sitting and listening, which is really good because it's fun. You like listen to it more and remember it more.
Have you got your cone done yet? It's superb to have outside agencies offer their assistance to create a practical package. We've done quite a good double act here today. I feel that we've both supported each other during the day, and it's been very beneficial for the children.
I think the children today enjoyed themselves, which is one of the main aims. But they also got the chance to hear a few technical terms used and have the terms explained to them, and then put them terms into use by building and then firing the water rockets. We used air pressure to push the water out when it got to a certain pressure and cause the rocket to lift off the pad. I told them a few basic laws of physics, Newton's law, reaction and action, explained that water cannot be compressed, and we talked about the fairness of the test.
Kieran, that looked like a lot of fun to me. Do you think it was inspiring for the children?
Absolutely. I couldn't say enough good things about that. It gave the children an opportunity to see a working adult come into the classroom and demonstrate to them some very exciting things that they can do. They were able to make rockets, all different shapes and sizes of rockets, and actually get to understand a few of the physical principles involved in getting those rockets to launch and what's happening. And there was a bit of a competitive element there as well, where they were timing how long they stayed up in the air. So I thought it was fantastic, and the children were obviously had a passion for it and were very excited. And
do you think those special moments that you particularly stick out in your memory of your primary school days are important in terms of later educational aspiration?
I think those first times that you come across something as exciting as making a rocket and a water rocket, you'll always remember the first time. So I think it's very important to get it right and to see that it can be exciting, and that's to see that when you leave school and become an adult and go into engineering or something, that you can see that there's a benefit to you, and what you learn you can take with you and use creatively, perhaps in an invention or something that you do in the future. And from little acorns, great oak trees grow.
Maria, bringing in outside experts, do you think they're good role models for primary school children?
Yeah, I think that's a really excellent idea, and one that I'd like to hear more about. I think if in our school we have a very innovative scheme. We have an Imagineering club where a volunteer parent comes in, an engineer, on a weekly basis and does similar experiments with the children. But it's only available for a few privileged children who can attend the club, and it would be really nice to think that that kind of exercise and experiment was available to all the children.
I mean, Anne, this is a scheme, obviously, I think a lot of parents will see that and think, well, why haven't I got that in my school? How widely available is it?
I think it's fairly widely available. There's not a huge take-up with schools on this kind of thing, although it's to be encouraged wherever possible. It's great to see it happening. It's lovely. Those children had a fantastic time and a great lesson. The principles that he was talking about teaching them, things like Newton's law and pressure, tend to come a little bit later in the curriculum. So I think as a first experience and an initial idea to get them going and fire their enthusiasm, as Kieran was saying, it was great. Just whether it was actually part of the primary curriculum as such, it perhaps wasn't, but I think as an experience for the children it was great.
But we all felt he was a good role model. I mean, the potential is there obviously for somebody to be not such a good role model if they're coming in from outside. Do you think that could be a problem?
It can be. I think one of the things that's important that we actually saw with the set point scheme there is that the outside people and the teachers work together and plan together to make sure that what they're doing actually matches in with some of the schoolwork that's going on. And so that way we can make it a meaningful experience.
I mean, Maria, we've seen some other examples in the programme of different types of experts coming in. Did you feel that the quality was variable between them?
In the examples that you showed us, I thought the quality was good across the board, but it was nice to see the female engineer on a later programme, particularly for the girls in the class. I think there is generally traditionally a poorer uptake in the science subjects later on in school, and it would perhaps be encouraging for the girls to see a female engineer coming into the class.
What about trying to tap into specialist skills that parents may have as scientists and try and bring them into the school rather than outside experts who have no connection?
Yeah, I mean, I know that our school does that, and I know other schools locally that do that, and I think it works very well. I mean, children, I think, like to see their parents coming in to talk about their subject. They're proud to see their parents participate.
And the planning with the school is obviously the key then. I mean, could it have negative effects if the expert didn't explain the concepts correctly to the children?
I think one of the things we know about children's learning is they do learn much better if they are engaged with that process. So rather than having an expert tell them when it may go over their heads and they don't quite engage with it, one of the art of teaching is to find out the children's idea, match it with the scientific idea, and try and blend the two together and get the children actually learning it for themselves. So when you get an outside expert in, they're perhaps not skilled in some of those arts of teaching. That's not to say they're not brilliant role models, that they're giving children a wonderful experience, and it's certainly something that's well worth doing.
Well, to explore these ideas further, let's look at our next clip where we can see children learning about gravity, one of the most difficult science topics. In the clip, we visit Zoe Lowe again with teaching assistant Linda Williams and her Year 6 class. The children are using force meters and trying to distinguish between the terms weight and mass.
Are you looking at weight or mass? In newtons in a gram. Times 10 will be 300.
Anybody got any measurements? Tony, I'm going to pick on yours. And what did you measure the globe to be?
9.
9 newtons. Anybody work with a chair? Sam?
It was 30...
Go on, help him out, Tom.
Well, it's 30 newtons and 300 grams.
OK, we'll come back to that in a minute because you've got grams drawn down there as well. Maddie?
We did the chair as well and we got 30 newtons and 300 grams.
In your books, what I'm going to want you to do is, I've got up on the board 3 sentence starters really, but I would like you, using all the things that we've talked about. Now, Astro Bear, our little friend, was somebody that helped us to think about mass and weight. We've also got the equipment that we have used that is connected to weight. We've got all our keywords up on the board. When you open your books up, what I'm expecting to see in there are some description of what you've learnt about those 3 things today.
Mass is the stuff we have inside us.
Wow.
Gravity on the moon is so little compared to the amount the Earth makes.
So Maria, weight and mass, these are quite complicated subjects now. Do you think she tackled it well and that the children were starting to think in a scientific way?
Yes, I do. I think it is quite a complicated subject to teach, but she again had the keywords up on the board and she used the Astro Bear and the other resources very well. They were available to each table. And after doing the experiments, the children had to explain what they did in their own words using the sentence starters, so she was clear that everybody understood the message that she was trying to get across.
It's complicated for parents though. I mean, did you know the difference before you started watching the lesson between the two?
I had to think about it very hard, very carefully. As I say, it seems a long time, you know, I think when I was at school, I don't remember doing that in primary school, and I was a little bit surprised that they were doing that in Year 6 again. And that I am often surprised by the things that they're taught in science at school, pleasantly surprised, and the children bring subjects home that they might want to explore a bit further, deeper at home.
And what sort of help would you want then to be able to help them to do that?
Well, they you know, again, they'll advise us at school as to where, if we don't know ourselves, where to obtain information about a particular subject, websites that might be useful or books that might be useful, references, and that might be included in the child's homework on some occasions, which is very useful. And even projects that we can do with the children, how we can relate everyday activities at home to their science projects that they're doing at school, such as cooking or, you know, if you're bathing the child, the younger children, you know, weights in the bath, what sinks, what floats, that kind of thing, and relate it back to perhaps what they're doing at school.
And do you think it's reasonable for parents to have to invest all this time in understanding complicated scientific concepts?
I don't think it's going to happen in reality. I think it's too much to ask of any parent to have to understand all the sort of more complicated issues. But one of the ways that parents really could help is by helping their child to recognise those bits that they think they're having trouble with. So if you can work with your child to say, well, that's a bit that's causing me problems, then the child can go back into school and say to the teacher, that's a bit that's troubling me, and hopefully the teacher can deal with that.
Kieran, do you think it's reasonable, though, that parents should have to have this quite a high level of scientific knowledge to be able to support their children?
I know there's always reference books, and now we've got the internet, that you can very quickly find the exact answer to, or the exact explanation of a subject, and you know you're going to get it right most of the time.
But have you got the time to do that? If you're an average parent, have you got the time to be on the internet looking up scientific terms?
Personally, I have to make that time, and I can see it with my children, and they're only 6 and 4. I can see that they are going to be asking me more and more difficult questions, and I need to be able to give them the answers rather than fobbing them off all the time and saying, oh, I'll tell you on the weekend. So I do think we need to have easier access, and I do think we need to be prepared to make the time to answer those questions for the children properly.
Maria, do you think science ought to be made a special case of? Because it is so different maybe to English and maths, and parents, you know, most parents would read with their children anyway, but they may not sit down and look up scientific terms on the internet.
Speaking as a parent, I think it's enjoyable sometimes when the children bring questions home to find out the answers together and explore them. And not everybody has access to the internet, not everybody has computers at home, but there's libraries that are accessible to everybody. We regularly use the library and go down and explore the answers to questions together.
So you think the earlier the better? I mean, you've got no problems with children of 4 or 5 coming home with these difficult concepts and trying to help them with that?
No, absolutely not. I think it's necessary today, and it's enjoyable.
Well, I think most parents would agree with that comment, but we have to end it there. You can have your say, though, by emailing parents@teachers.tv, and you can find all the information about the programmes you've seen and more on our website at Teachers TV. Details at the end of the programme. Thanks to my guests, Anne, Kieran and Maria.
Goodbye.
Bye.
Bye.
And for myself, Fiona Miller. Thanks for joining us, and until next time, goodbye.